Welcome to section 6.5. We're looking at the graphs of tangent, cotangent, cosecant, and secant functions. Some of our objectives in this chapter are to graph the tangent function, y equals tangent x, and the cotangent function, y equals cotangent x. Graph functions of the form y equals a tangent omega x plus b, and y equals a cotangent omega x plus b. Graph the cosecant function y equals cosecant x and the secant function y equals secant x. And graph the functions of the form y equals a cosecant omega x plus b and y equals a secant omega x plus b. So let's get started. First, let's sketch the graph of y equals 2 tangent of x minus pi over 2. Now, something that we should know about tangent is that tangent is normally undefined at certain points, and those would be at negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and so on. It goes on forever like this. But in this particular case, we're moving it over by pi over 2. We're subtracting a pi over 2, so we're moving it over on the x-axis. So now we are undefined at a different place. So we will be undefined at negative pi, 0, positive pi, and so on. We've moved it over. So what does this mean? Well, let's take a look at some of our values. Our x values and y values for this function. So if I plugged in a pi over 4, for example, and I'm putting my pi over 4 in as my x, then that's going to give me out a negative 2. And if I put in a pi over 2, well, that's going to give me out a 0. And let's do one more, 3 pi over 4. Well, that's going to give me out a positive 2. Now, what made me choose these values? Well, I know that 0, it's going to be undefined, and pi is going to be undefined, so I'm looking at some points in between 0 and pi. So if I cut pi into 1/4, 1/2, and 3/4, then I can find some values on the tangent that are really useful to me. So what does this look like? Oops. Well, it's going to be undefined at 0. It's going to be undefined at pi over 2, 2 pi, negative pi, and so on. So this is 0, this is pi, this is 2 pi, negative pi. And everywhere else, it's just a stretched tangent. So tangent is amplified by 2. And what does that look like? Well, it looks something like a stretched up tangent. And based off of our data, this should be a pi over 2. And we can see pi over 4, a negative value, 3 pi over 4, a positive value. So it's all working out really well. One thing I suggest is after you make your sketch, to graph it in your graphing calculator to double check that you're going at it the right way. Let's do another one. Y equals negative tangent of pi x. So, first of all, we have a negative. That tells us that we are flipping the graph vertically. And then we have our period of pi over omega. So pi over pi, which is 1. Then we've got normally undefined at points like negative pi over 2 and pi over 2. We talked about that earlier. Now we're undefined at negative 1/2, positive 1/2, and so on like that. Now, why is this happening? Well, because we have a period, a new, it's kind of thinking of it like instead of taking the whole period of pi, which is approximately 3.14, we have to do our whole cycle in 1. So it's cutting it down by almost a third. It's cutting it down by pi to be exact. So we're kind of squishing our tangent like an accordion. Here we go, let's try to graph him. If 0 is here, and 1/2 is here, and 3/2 are here. Over here I have negative 1/2 and negative 3/2. So if we flip it, it's going to be going downward this time. Now, since I am working in a period of 1, I'm undefined at negative 1/2 and 1/2. And instead of going upwards, I am going downwards. Something like this. Now I know you're jealous of my perfect graphing skills, but if yours don't look as pretty, that's totally fine. I'm just kidding. I know that this graph looks gross, but we get the general idea of what it's supposed to look like. We're just sketching at the moment, so it doesn't have to be absolutely perfect and beautiful. Okay, now we're gonna graph cotangent of 2x. Here we have a period represented by pi over omega, which tells me pi over 2, because we have a 2 right there as our omega. So a period of pi over 2, if I see what my cotangent looks like, I'm just going to start it at 0. And over 2, since that's our period. And I know since that's my period, that's where it's going to reach its asymptote. And that's going to tell me it looks something like this. And there we go. Cotangent of 2x. Okay, now let's take a look at some secant and cosecant to finish off our lecture today. Y equals 3 secant of 2x. Well, we're stretching this by 3. Vertical stretch. And our period, represented by 2 pi over omega, is 2 pi. Our omega is 2, which leaves us with pi. So every pi we get a new cycle. Now, what do we know about secant that can help us? Well, we know that secant is 1 over cosine. And I'm going to rewrite this as 3 over cosine of 2x. Now, writing it this way not only helps us when we calculate them, but we can also put them into our graphing calculators this way. So when you're double checking, go ahead and put it 3 over the cosine into your calculator to double check that your graph is coming along the right way. Okay. So if I'm looking through, I am, instead of having a cosine, which would look something like this. Cosine starts at 1, and it goes down and comes up, and it does that on both sides. That would be a cosine, but remember, we had a vertical stretch by 3, so this is going to be 3, not 1. And this is going to be -3, not -1. We also have a cycle going 1 pi long. So if I'm going to graph 1 over cosine, instead of following this cosine, which is the dotted line in yellow, I'm doing the inverse of it, 1 over cosine. So I'm doing the opposite everywhere I see that. Which shows me where my asymptotes are going to show up. And it would even be more helpful if I had labeled the graph. So this distance here between the two asymptotes, that's where we're having our one cycle happen. So it's 1 pi long, making this pi over 2 and this negative pi over 2. Because the span of one whole cycle will make pi. And then since this whole cycle goes 1 whole pi, we go from pi over 2 to 3 pi over 2. Same thing on the negative. Now, we have a lot going on in this graph, but our function itself is represented by the purple line. The purple is representing our secant function. We are just using the yellow cosine as a guide. Let's do another. Secant of x minus pi over 2. So here we have a horizontal shift happening. Which means every time we plug in an x, we're moving it over negative pi over 2. Now, what do we know about secant that's helpful? It's 1 over cosine. So we're looking at cosine of x minus pi over 2. So again, I'm going to start with the cosine graph to help guide us on how to graph the secant. Now, cosine does something like this. And that will help us to graph 1 over cosine. This is a 1. This is a negative 1. And this is pi over 2. 3 pi over 4. Oh no, 3 pi over 2. Okay. And I suppose I can label this side too. And now that we are graphing 1 over cosine, we can put in our inverted cosines. But before I do that, I want to take into account that we have a horizontal shift of pi over 2. So what I'm going to do is, instead of putting in the asymptotes, normally it would be here. It's a shift negative pi over 2, so it's gonna have to go over. So it's gonna shift pi over 2. And that's our asymptotes. And now that we have our asymptotes in, we can put in our graph. So normally I would put this one here because of the guide of the cosine graph, but it is shifted pi over 2, so it's gonna go here. And this one's gonna go here. This one's gonna go here. And this one's gonna go here. And now we have our secant graph. Okay, let's graph cosecant of x over 2 plus 1. So first we have a vertical shift of plus 1. We have a period represented by 2 pi over omega, and that is 2 pi over 1/2, which is 2 pi times 2, which is 4 pi. So one cycle lasts 4 pi. Now, what do we know about cosecant? Well, it's 1 over sine. So we're looking at 1 over sine of x over 2 plus 1. So let's get a guide going. And my guide this time is going to be sine, but it's shifted up by 1. So instead of going from 1 to -1, now it's going to go from 2 to 0. So sine will start, let's label these 0, and we'll go 2 pi, 4 pi, and a -2 pi, and a -4 pi. And like I said, we're going to go up to 2 because it's all shifted up by 1. Now, as I was saying, sine starts here and is going to go up like this, and is going to come down like this, and up, and down, and up, and down. Yep, perfect. Now, since I'm doing 1 over sine, everywhere I see these values, I'm going to invert them. And anywhere like this, where my graph isn't connected, I know it's reaching its asymptote. That's on 2 pi. And that's on -2 pi. And there we go. The purple is representing our cosecant graph. These ones take a little bit more time and a little bit more understanding of what's happening on the graph. Please make sure that you are reading the chapter and following your guided notes to get the best understanding of what's happening.